Hello and welcome to this video where we will take the model we just built using Cplex and then test whether we can solve it and how we can then read the solution and maybe manipulate the model a bit. So our main class now reads a graph, then builds a model, and then of course we want to do something with the model. We want to solve it. I will add a method for that, and those methods have to be called by the main class, so let's make it public. Let's say public void solve. This will probably also throw an ILO exception, so I'll just hand it in right now. And basically everything we need to do is just call cplex.solve. So first we were only building the model. It's just created in memory. We do not solve it yet. But now when we call this method, Cplex will do its work. And we can call it from in the main class like this. So we say model.solve. Now if we run this, we have to, I didn't save the model. So now I saved it. Let's run it. And then Cplex is very fast. We get all this additional data. So it found an incumbent, etc., some information. And it basically solves everything in 0 seconds. So that's quite nice. It's a small model. It's really fast in this case. Okay, but that's, then the model is solved. But of course, this does not tell us the solution. So we should also maybe start with just saying which items are selected. So let's give back the solution as a list. So we give back a list of items, and these are the items that are selected. This can also generate an exception. Import the list. So let's use an array list here and then return the result. Organize the imports. And what we will do is iterate over the items again. They were in the instance. Get nodes. And now what we want to do is first retrieve the variable that's associated with the item. We have our var map. We get the item. And now we want in our current solution to find the value that's assigned to this variable. Double value is, and then we have to use Cplex again. Get value, and we can use any numeric expression or a variable. So I will just use the variable, and now this double will contain the value. Of course, in Cplex, doubles are not always precisely 1, so it may be tempting to write something like if value is equal to 1, but this is a bit dangerous. So it's better to use a comparison like this, 1 minus 0.0001 or something. Or since we know there are integers anyway, we can even write 0.5. So numeric precision is an issue. It's beyond the scope of this video to go into depth about it. But you can run into some weird things if you are not careful there. So if the value is bigger than 0.5, then apparently the item is selected. So we add it to our result list. And if it's smaller than 0.5, it's apparently 0. And we add it. So this will get a solution. And what we can do here is just print it out. Get solution. Let's run the model, and then in the bottom we see here that the result is a list of 2 items, weight of 5 and a weight of 2. that are both selected, but the third item is apparently not selected. And indeed they are together 7, so the capacity of 8 is not violated. If we now would increase the capacity to 20, then we can easily select all our items. We can see that 3 items are selected. Profit 10, weight 5, weight 2 and weight 7. If we just have weight 3, capacity 3, then our result list will only contain a single item. So you can really see that this capacity is correctly used by the model. If you don't like seeing all this Cplex output all the time, you can also disable it. We can go to the model and write something like Cplex.set out to null. If we now run our main class again, we see that just the result is shown. So this is how we can extract the solution again from Cplex. It can also be interesting to manipulate the model after we solve it. So basically resolve it. We can do something like that, create a new method where we fix a variable. Void set item, and then we use an item and a boolean, whether it's enabled or not. So what we can do is take the variable for it, var is varmap.get the item, and what we now want to do is say if enabled, we can set the lower bound of the variable to 0 and set the upper bound of the variable to 1. Again, we have this ILO exception. If it's not enabled, we can set the lower bound to 0 and the upper bound to 0 as well. So then it has to be 0. So after we solve it like that, we can, let's make this capacity 8 again. We can take an item from our instance, get nodes and get the first one, for example. And then we can say model.set item I is disabled. We can solve the model again, print the model again, and if we run this, we can see that one of the 2 items is being disabled. So this one is not allowed anymore, and for an instance of 8 only the item with a weight of 2 is selected, which does not seem optimal, but this is probably because of the precedent constraint. So the item with weight 7 and profit 15 cannot be added due to the precedence constraint. So yeah, that's what's going to happen. Maybe if we make it 9, they will both be added probably. Is that not enough? Oh, maybe it depends on the item we just disabled. Yeah, that's possible. So we can disable the second item, for example, like this. And then we don't have any solution. So then all the values are 0. So yeah, you can play around with it like that. If you want to unfix the item again, you can say something like I is enabled again, resolve the model, print it. Let's take the first item like we had before, and then you see that we just get the old result again. And Cplex resolves the model, so if it already has a good solution and you change some upper bounds and lower bounds, it will just start with the solution it had and just try to make it feasible from there again. Finally, it could be useful to detect whether there is even a solution, whether it's feasible or not. So we can create a Boolean method is feasible that extracts this information from the Cplex model. We can just say Cplex is primal feasible. Main, and we can say something like, we can also print this, so we can just say, is it feasible? Is feasible. Now we can see that indeed it turns out to be feasible. And this can be useful if you have a more complicated algorithm where you really want to have a look at whether the current model is feasible. One last thing about memory. So this Cplex runs outside of the Java virtual machine and it takes up memory in there. And it's a good idea if you're done with your model to clean it up. So normally objects in Java get cleaned up automatically by the virtual machine. With Cplex we have to tell Cplex to perform a cleanup. So I'll create a cleanup method and I'll say cplex.clear model, and we can even say cplex.end. Again, this will probably throw some exceptions. And when we're done with the model, we can clean it. So we can say cleanup. Be aware, after we do that, we cannot do anything with the model anymore. Then we will get a serious exception. So if we say something like set item false after we clean up the model, we will get an error. So here Cplex gives a null pointer exception, or if we try to solve it, probably we get the same kind of problem. So it's a good idea to clean everything up when you're done with the model, especially if you create multiple models in your algorithm or those kinds of things. Build a new model every time, clean them up when you don't need them anymore. If you just run your program once, it's not that important, you can leave it there. But if you don't, you may end up getting out of memory errors at some point, if you build many models in your program and forget to clean them up. Okay, so this is a quick overview of how you can use Cplex from Java. I hope it's useful to you, and the files you can download from GitHub. There will be a link on your course information. So thanks for the attention, and good luck with your assignments.